Hi guys, this is Miss Scott here, and we are going to learn the last section of geometry, or chapter 7 in geometry, which is the law of sines and the law of cosines. Here is your bad joke of the day before we get into that. Why are kings and queens so good at measuring? Well, it's because they're rulers. All right. Okay, so today's lesson, again, dealing with the law of sines and law of cosines. Now, every other type of triangle we've used in this chapter has been a right triangle. That's the only types that we so far know how to find missing sides in. So this lesson is going to focus on if you have a non-right triangle, how can you find missing sides and even missing angles, okay? So first of all, the law of sines helps if you have a triangle in which you know a side and another angle. So you can use this type of formula for side angle or for angle side angle. All right. So if you are given a side angle triangle, what you can do is find a missing length or missing angle measure. So this is to find a missing angle. And if you know angle side angle, you can find a missing side. And we'll look at what that looks like in a little bit here. So it's just some tips for how you use this. Notice in the law of sines, it's three ratios set equal to each other, and the angle opposite, so the angle opposite the side uses the same letter, but it uses a capital letter instead. So what I mean by that, for example, is that angle A is across from little a here, angle B is opposite side B, and angle C is opposite side C. So that's how these ratios here are set up. So notice we have sine of C over C, we have the sine of B over B, and then we also have the sine of A over A. Now when you set up this formula, typically you only use two of these, and then notice that we have a proportion here, and then we cross multiply to find our missing sides. So we'll get into how to use that to solve in a little bit here. But I just want to show you guys that this really does work. So using this triangle down below, we're going to verify that the law of sines is true using this triangle. So let's just take a look at some pairs. So I'm going to start with angle D. And angle D is across from this side. So when we set up our ratio, we're going to say the sine of 41 degrees divided by 29. And then we're going to do the same thing for the next ratio. So if we go to angle E next, this is going to be the same thing as the sine of 84.5 degrees. And we have to put that over the side opposite, which is 44. And lastly, if we take a look at angle F, it's 54.5 degrees. So we'll take the sine of 54.5 degrees and we will put that over the side opposite, which is 36. All right, and it turns out these are all equal. So if you would plug in the sine of 41 degrees divided by 29, you're going to get 0.0226. If you do that same thing with sine of 84.5 divided by 44, you get 0.0266. If you do the sine of 54.5 divided by 36, hey, guess what? You get 0.0226. So it does work. If you don't believe me, pause the video, plug those in. I'm guessing you're going to get 0.0226 for all three of them. Okay, so that's how you can use that, just a little bit of practice with setting it up. Now let's look into putting it into practice so that we can find some missing sides. So in your notes, we're actually going to alter this question a little bit, and it should be altered in your notes. If it's not, go ahead and change this. We're not going to find the value of B. It's a little more complicated than I want to get into here. we are going to actually find the measure of angle C. And that is what your notes should say. All right, so let's take a look here. Now, when you're setting up using the law of sines, the law of cosines. No, law of sines. I was right the first time. You're always going to find a pair. And what I mean by a pair is you have an angle and the side opposite. That's always your starting point if you have it. Okay? So we have to set up sine of 51 over 18. Now, since we're trying to find angle C, we have to use this side over here. So we're going to leave it as the sine of C and put it over 17. Since we don't know angle C, we have to leave that variable as it is. All right, so now we can go ahead and cross multiply. We're going to do 18 times the sine of C is equal to 17 times the sine of 51. And now our goal here is to get C by itself, so let's go ahead and divide by that 18 to get sine of C by itself. So if we divide by 18, these will cancel, and then we end up with the sine of C equals. Now here's where you can plug into your calculator. Let's just do 17 times the sine of 51. Make sure if your calculator gives you a parenthesis here, you close that up, and then divide by 18. If you do that, try to do as many decimal places as you can in order to make sure your answer is accurate. So I'm actually going to do 5 decimal places in this one, which is a little extreme, but hey, I want to be really accurate. We're going to say that sine of C equals 0.73397. Okay, and now we need to get C by itself. So if you remember, to get rid of sine, we have to do the sine inverse. And just like with anything we do in math, if I do something on the left, I have to do that same thing on the right. And just be aware, guys, when you plug this in, the sine inverse should actually be in front of that decimal. Okay, so these will cancel, and we will just be left with C. Go ahead and plug in sine inverse of that decimal, and you should get about 47.2 degrees. All right, so there is our angle C. All right, that's how you can set it up to find a missing angle. If you're asked to find a missing side, things are a little bit trickier. So we're going to look at a word problem of just that. It says to solve the word problem below. So we have an airline pilot has to detour around a group of thunderclouds by turning left at an angle of 21 degrees from the flight path. Fly for a while, turn right, and intercept the original path as shown. How far did the pilot go? All right, so let's label some stuff here. I know this is going to be pretty crazy, but I'm going to call this triangle A, B, and then this point C. So if this pilot was going to fly directly from A to B, it would be 70 kilometers, but he doesn't want to go through this thunderstorm, so he's going to go to point C and then back to B. All right. If you are trying to find a missing side, so in this case, we want to know how far it is from A to C and then from C to B. Let's call this lowercase a, and let's call this lowercase b. So if you have this type of problem where you have an angle and then a side and an angle, and you're trying to find a missing side, didn't mean to make you dizzy there. The first step is to find this angle. So find the unknown angle first. All right, so step 1, we're going to do 180 minus 21 degrees minus 35 degrees. And then we find that angle C is 124 degrees. All right, so that's our first step. Now we have a pair. We have an angle with its opposite side. So we're going to begin the problem by setting up the sine of 124 over 70. All right, and I want to find A first, so I'm just going to do this in alphabetical order. We're going to set up that equal to the sine of 21 over A. That's our opposite pair here. So if we're going to use 21 degrees, that has to be across from little a. All right, let's go ahead and cross multiply. So we have 70 times the sine of 21. And that's going to equal a times the sine of 124. Okay, and we are trying to get a by itself. So in order to do that, we are going to need to divide by the sine of 124. All right, so now is when you can get your calculator handy. These are going to cancel over here. And let's plug in 70 times the sine of 21. Again, make sure if your calculator gives you parentheses, close up that parenthesis after the 21. And then divide that by the sine of 124. If you do that, you end up with 30.3 as your A value. Okay, and now we just have to find B. So that's our second part here. We're still going to set up the sine of 124 over 70. But now over here to find B, we're going to use 35 degrees. So we'll set up sine of 35 degrees over B. Go ahead and cross multiply again. So now we're going to do 70 times the sine of 35 is equal to B times the sine of 124. And again, we have to get B by itself, so we'll divide by the sine of 124. All right, so B's cancel over here. Go ahead and plug that into your calculator. 70 times the sine of 35 divided by sine of 124. If you do that correctly, you should get 48.4 for B. So then to figure out the total that the pilot flew, it wants to know how far he went. We're just going to add A and B. So if we add that 30.3 to that 48.4, he's going to end up going 78.7 kilometers. So not too much further than his original flight path. 8.7 kilometers is not far at all, especially if you're in a plane. All right, so that was kind of 2 sine problems in 1. All right, so if you missed the law of sines lesson, that takes care of that. Now, if you're just tuning in here to get the law of cosines lesson, that's the next half of this video. So that's going to be this formula. So the law of cosines, I'll be honest, I think these are a little bit trickier than the law of sines. So if you're having any difficulty with this, you come find me. We'll do some practice together. So this law gets used if you have a side-side-side triangle, or if you have a side-angle-side triangle. And you're going to use it for side-side-side to find a missing angle. You're going to use this law for side-angle-side if you want to find a missing side, which is the easier of the two. So this one is easier to find missing sides, just like in the law of sines. All right, now one thing to be aware of, I'm going to move this down so I can talk a little about what's going on here. This is actually the Pythagorean theorem if you ignore the stuff at the end. What that stuff at the end does is it corrects for this not being a right triangle. So it's the Pythagorean theorem with a little bit extra. That little bit extra makes it work for any type of triangle. All right. One other thing to notice is that this side is always across from the angle that you're going to put into the cosine portion of the law. Okay, so just give yourself a little note here. This is the side and its opposite angle. So just FYI for future reference. And then A and B, whatever those happen to be for your type of triangle, those are just the other 2 sides. All right, so we're going to practice using that. I'm just going to pick one of these angles here just to kind of show you guys how you set these up. So just let's go start with angle D. we're going to set up just using this to practice how to put it into the formula. So angle D is across from side D. So the 29 side, we're going to square that. And then we're going to set that equal to the other two sides squared. So 36 squared plus 44 squared. And then we're going to do minus 2 times those two sides, 36 and 44. And then we're going to times it by the cosine of 41 degrees. All right, now everything on the right side of this equation, you can plug this all in one line in your calculator. Don't overcomplicate things here. If you do that, you should end up getting 841 if we round to the nearest whole number. And it turns out that 29 squared is also 841. So this is just a little example to show you guys this really does work. We're not making this stuff up. And just a little practice of how you plug this stuff into the calculator. So now let's get into an example where we can use it to find a missing length. All right. So we're asked to find the value of B. So we're going to find side B. So if we want to find this side, we have to use the angle opposite it. We'll set up B squared is equal to these other two sides squared. So it's going to start out by looking like the Pythagorean theorem. But we can't use the Pythagorean theorem because this is not a 90-degree angle. So that's why we have to put this extra stuff at the end. Minus 2 times 45 times 43 times the cosine of the angle between, which is 88 degrees. And again, you can plug all of this in one line in your calculator. Make it simple for yourself. So if you do that, I'll give you a sec if you need to pause, give it a shot. But if you do it correctly, you are going to get 3,738.94 if you round that to 2 decimals. And remember, that equals B squared. So the last step here is we're going to take the square root of both sides, and we'll get B by itself is going to be about 61.1. And that seems like a reasonable answer if we look at that triangle. I think that makes okay sense. All right. We have one more example to take care of. So the last example, I think, out of all the ones we've done is probably the trickiest. So we're going to end with a bang here. This is what you have to do if you're asked to find a missing angle and you have a side, side, side. All right. So step 1, we're going to find the largest angle. Well, if you remember way back in chapter 5, we learned that the largest angle is across from the largest side. So we're going to set up 6 squared as our c squared, you can think of it as. That's going to be 5 squared plus 4 squared. All right, so that would be the Pythagorean theorem with the side across set equal to the sides surrounding the angle. And then we have to put that extra at the end, so minus 2 times 5 times 4 times the cosine. Now we don't know the angle, so we have to leave that as b. All right, let's simplify things a little bit here. So first of all, 6 squared is 36. Now on the other side, you have to keep these two parts separate. The 5 squared plus 4 squared you can plug in. If you do that correctly, that's going to end up being 41. And then separately here, we're going to do 2 times 5 times 4. So 2 times 5 is 10. 10 times 4 is 40. So this is going to be minus 40 times the cosine of b. Now here is where I always see students making mistakes. They want to combine these, but those are not like terms. That 41 is just an integer. The minus 40 is being multiplied to the cosine of b. So you can't combine them, so don't. All right, so how we have to take care of this is by first getting rid of that 41 by subtracting it. And that is always going to be your first step when solving this type of problem. You subtract that number in front. So this ends up being negative 5 equals negative 40 times the cosine of b. Now we're going to get rid of that negative 40 by dividing it on both sides. So these negative 40s here cancel. And negative 5 divided by negative 40 is 0.125. And now over here, we're left with the cosine of b. All right, last step, we want to get b by itself. So in order to do that, we need to take the cosine inverse of both sides. So then this cancels this. And if you plug in the cosine inverse of 0.125, you will get 82.8 degrees. And that's going to be your angle B. All right, so you can always follow those same exact steps for this type of problem. I would recommend using this example to help you out with your assignment. But if you get stuck, feel free to come find me, ask questions, leave a comment or question in the comment section down below, and I can get back to you that way. Or send me an email if you can't find me, and we will get it figured out. All right, well, I appreciate you guys tuning in here. Thanks for sticking around for the whole video. I know that was a longer one. Make sure you comment if you need to, and we will see you guys next time. Take care.